Very good morning, students. The today's topic, haloalkanes. What are haloalkanes? Now I am discussing the synopsis. Haloalkanes. What are haloalkanes? Haloalkanes are the aliphatic or aromatic hydrocarbon. So these haloalkanes are formed by the replacement of what hydrogen atom of what aliphatic or aromatic hydrocarbon by halogen atom. It results what haloalkanes and what haloarenes. So what are halogens? Cl, Br, I and what F. So these are called what halogen atom. Where the hydrogen atoms of aliphatic and aromatic compound are replaced by what? The Cl, Br, IF. So these are called what? These are called what? Haloalkanes and haloarenes. And in case of haloalkane, the haloalkane contains what? The halogen atom, and the halogen atom attached to what? Attached to what? sp3 hybridized carbon. So, but in case of haloarene, where the halogen atom is attached, it is what? sp2 hybridized. It means, so where the halogen, this is called X is called what? Halogen. What are halogen? Cl, Br, I and what F. So these are called what? Halogen. These are called what? Halogen. Okay. So these are called what? Halogen. So where these halogens are attached to what? The halogen is attached to what? Haloalkane. These are sp3 hybridized. Where the halogen is attached to what? Haloarene. So these are what? sp2 hybridized. Okay. Now the next I can discuss what? Classification. So the next is the classification of haloalkanes and what are haloarenes. So here, so what are classification? Yes, here three classifications are there. Yes, the first I can discuss here. The first classification is here. The classification of what? Haloalkanes. So on the basis of what? Number of halogen atom. So these haloalkanes are three types. One is monohaloalkane. Why it is called monohaloalkane? It contains what? Only one halogen atom. It contains what? Only one halogen. It contains what? Only one halogen. So that's why. So these are called what? Monohaloalkanes. And next, what are the dihaloalkanes? The dihaloalkanes, it contains what? So this is the dihaloalkanes, means it contains two halogen atoms. It contains what? Two halogen atom. It contains what? Two halogen atom. The two halogen atom is called what? Dihaloalkane. When this in this dihaloalkane, the two halogen atom is on same carbon. The halogen atom is present on the same carbon. So this is the special type. It is called what? Geminal dihalide. It is a dihaloalkane. Why it is called dihaloalkane? It contains what? Two halogen atom. Two halogen atoms, Cl number 1, and this is what? Cl is what? Two halogen atoms. But these two halogen atoms is on same carbon. So this type of haloalkane is called what? Geminal dihalide. And the next is what here? The next is this is the dihalkanes are two types. One is geminal dihalide. Next is what here? The next is okay. The next is vicinal dihalide. The next is what? Vicinal dihalide. What is this vicinal dihalide, my dear students? I am discussing here. So this is what is a vicinal dihalide. Why it is called vicinal dihalide? Here the two halogen atoms. This is halogen number 1 and this is halogen number 2. These two halogen is on adjacent carbon. Adjacent carbon means one halogen is on first carbon and the second halogen is on second carbon. So these two halogen atom is on adjacent carbon. So this type of haloalkane is called what? Vicinal dihalide. And next is what? The next classification is trihaloalkane. What is the trihaloalkane? It contains how many halogen atom? It contains what? 3 halogen atom. It contains what? 3 halogen atom. What are those 3 halogen atom? Halogen atom number 1, halogen atom number 2, halogen atom number 3. Here also 3 halogen atom. So that's why. So this is called what? Trihaloalkane. And the next is what here? The next classification. Okay. So the next is here. Now the compound containing sp3CX bond. Okay, the compound containing sp3CX bond. Okay, my dear students. So here I am discussing here. So the compound containing sp3 carbon. It is what very important is what? sp3 carbon of what? CX bond. So here, so this the compound containing sp3 carbon of CX bond. So these are what? Alkyl halide or haloalkanes. So in alkyl halide, the halogen atom is bonded to what? Alkyl group. They are further classified as primary and secondary and what? Tertiary. What is this primary? What is this primary alkyl halide? The primary alkyl halide means what? Where this is called what? I can here this is CH3. Okay, this is what? CS2 and this is what? Br. So this is an example of what? This is an example of what? This is an example of what? Primary alkyl. In this primary alkyl, right? So this is the halogen. This is what? Br is what? Halogen. So the Br is what? Halogen. This halogen is attached to what? Attached to what? Primary carbon. This halogen is attached to what? Primary carbon. So this is called what? Primary carbon. This is called nothing but a primary carbon. The halogen is attached to what? Primary carbon. So it is called what? Primary alkyl halide. So why it is called primary alkyl halide? This carbon is linked to what? One carbon. This carbon is linked to only one carbon. So that's why it is called what? Primary alkyl halide. Example, this is the ethyl bromide is an example of what? Primary alkyl halide because it contains what? Only one alkyl group. That is what? R. This is R. Next is what? CH2. And what is the Br? Br is nothing but a X. RCH2X is the general formula of what? Primary alkyl halide, where this halogen is attached to what? Attached to what? Primary carbon. Attached to what? Primary carbon. So it is called what? Primary alkyl halide. And the next is what here? The next is secondary alkyl halide. What is secondary alkyl halide? Yes, my dear students. Now I am discussing secondary alkyl halide. Okay, just a minute. What is secondary alkyl halide? So in the secondary alkyl halide I am discussing, yes, this is what is the secondary alkyl. So here the example is there, CH3 and this is what? CH and this is what? CH3. Okay, this is what everybody? Br. Okay, this is what? Br. So here this is called what? Secondary carbon. This is called secondary carbon. So it is called what? Secondary carbon. Why it is called secondary carbon? This carbon is linked to how many carbon? Carbon 1 and carbon 2. So this is called secondary carbon because this carbon is linked to 2 carbons. So that's why it is called what? Secondary alkyl. How many alkyl groups are there? 2 alkyl. This is R1. This is what? R1. And this is R1 and this is what? R2. How many alkyl groups are there? 2. So this is R2. This is R2. So this is what? CX and this CH. But this Br is called what? Br is called what? X. This RCH2X. RCH2X is called what? Secondary alkyl. This is R1, CH3 is R1, another CH3 is what? R2. How many alkyl groups are there? 2 alkyl groups. And this is CH, this Br is called what? X. X is called what? X is called what? Halogen. This X is nothing but a halogen. So this is called what? This is called what? Secondary alkyl. It means, so this carbon is nothing but 2 degree. It indicates what? It is a secondary carbon. So that's why it is called what? Secondary alkyl. And the next is what here? The next tertiary alkyl halide. What is this tertiary alkyl halide? I am discussing tertiary alkyl halide. Okay, my dear students. Okay, tertiary alkyl halide. Okay, here. Next is tertiary alkyl halide. Yes, but this is now the tertiary alkyl halide. What is the tertiary alkyl halide? How many alkyl groups are there? R3. This is I am discussing tertiary. R3CX. How many R's are there? 1 R. This is R number 1. This is R number 2. R, this is 2 and this is what? RCH3 and this is what? Br. Yes. So this is called what? This is called what? Tertiary carbon. This is called what? Tertiary carbon. This is called what? Tertiary carbon. Why it is called tertiary carbon? This carbon is linked to carbon 1, R1 and this carbon is linked to R2 means alkyl group and this carbon is linked to R3. So it is linked to how many carbon? 3 carbon. R1, R2, R3. So that's why this carbon is called what? This carbon is called what? Tertiary carbon. Where this Br is what? Halogen. The halogen is attached to what? Tertiary carbon. So it is called what? Tertiary alkyl halide. Or in tertiary alkyl halide, how many R groups are there? R1, R2 and what? R3. This is what? R3. C is what? What is the Br? Br is what? X. So this type of alkyl halide is called what? Tertiary alkyl halide. Okay. The next classification. Okay. The next is what? The compound containing what? sp2. Okay. The next is what? One more example. Okay. Here one more is that I can discuss allylic halide. It comes here. It comes what? Allylic halide. So what type of is called what? Allylic halide. What is this allylic halide? So this is the halogen. Br is called what? Halogen. The Br is called what? Halogen. The halogen is attached to what? The halogen is attached to what? Anybody? This is the sp3 carbon. The halogen is attached to what? sp3 carbon. Next is what? Carbon carbon double bond. So this type of halide is called what? Allylic halide. And this is called what? Benzylic halide. So this is Cl is called what? Cl is called what? Halogen. And this halogen is attached to what? This halogen is attached to what? sp3 carbon. Next it contains what? Next it contains what? Benzene ring. Next it contains what? Benzene ring. So this type of halides are called what? Benzylic halide. So benzenic halide means, for example, if you take benzene, you take what? Benzene. To this add what? sp2 carbon. Sorry, sp3 carbon. This is what? Br. Br is what? Br is what? X. X means what? Halogen. X means what? Halogen. The halogen is attached to which carbon? The halogen is attached to what? sp3 carbon. Next it contains what? Next it contains what? Benzene ring. So the halogen is attached to sp3 carbon. Next is what? Benzene ring. So it is called what? Benzylic halide. And this halogen is attached to sp3 carbon. Next is what? Carbon carbon double bond. It is called what? Allylic halide. The next classification. Next is the compound containing sp2 carbon. Okay. The compound containing sp2 carbon. Okay. Okay. The compound containing sp2 carbon. Okay, my dear student. So this is the compound containing sp2 carbon. What is this sp2 carbon? Compound containing sp2 carbon. Here this is what? Cl. This is Cl. Cl is called what? Halogen. This is the halogen. The halogen is attached to what? The halogen is attached to what? sp2 carbon. It attached to sp2 carbon. Here is what happens? CS2. Okay, this is the double bond, and this is what? Cl, and the Cl is attached to what? The Cl is attached to what? sp2 carbon. It attached to sp2 carbon. So it is called what? It is called what? Vinylic halide. It is called, what type of halides are called vinylic halide? Where the halogen, Cl is called what? Halogen. The halogen is attached to what? Attached to sp2 carbon of what? Carbon carbon double bond. It is called what? Vinylic halide. So this is also, Cl is attached to what? Carbon carbon double bond. So that's why it is called what? Vinylic halide. The next is what here? Next is here. Next is the aryl halide. Next is what? Aryl halide. What is this aryl halide? Very important here. What is this aryl halide? In this aryl halide, this is aryl halide. What is this aryl halide? So this is the Cl is called what? Halogen. Yes. This is what? Halogen. The halogen is attached to what? Attached to what? sp2 carbon of what? Benzene. Or the halogen is directly attached to what? Benzene. So this is yes, my dear students. So this is the benzene. It contains what? Alternate single. This is the carbon. This is the carbon. All are what? It contains what? Carbon. So this carbon, it is a carbon carbon double bond. It is a carbon carbon double bond. So where the halogen is attached. This is what? Halogen. Okay, my dear students. This is called what? Anybody? Cl is the halogen. So in this case, what happens? This Br is halogen is attached to what? sp2 carbon of what? Benzene ring. sp2 carbon of what? Benzene ring. So this is called what? Aryl halide. The next is what here? Next is the nomenclature. Next is the nomenclature. Yes, in this nomenclature, first is what here? Okay. The first is what I can discuss. What is the nomenclature? This nomenclature, the first I can discuss here. So first common name of alkylides are derived by naming of what? Alkyl group followed by the halide. Okay, my dear students. Now is a common name. Yes. How many carbon? So this CS3, CS2 is called what? Profile group. It is called what? Profile. It is a profile. Br is called what? Bromide. And it is straight chain hydrocarbon. Straight chain means we can use what? N. N it indicates what? Normal. And this is called what? Everybody? So this is CS3, CS3. It is called what? Everybody? Iso group. And how many carbons are there? 3 carbon and 7 hydrogen. 3 carbon, 7 hydrogen is called profile, and the Cl is called what? Chloride. And here is also same here. So this CH3, CH, it is called what? Iso. So this is the iso. 4 carbons are there. Total how many carbon? 4 carbon. And how many hydrogens are? 9. It is called what? Butyne. And this Br is called what? Bromide. Next, what is the ipecaneine? Ipecaneine, how many carbons are there? How many carbons are there? 1, 2, 3. 3 carbon. 3 carbon is called what? Prof. Where the first carbon it contains what? Br. It is called 1-bromo-profile. And next you have to give the number. Next, what is the ipecaneine? Now it is the number carbon 1, carbon 2, carbon 3. So the Cl is on second carbon. It is called 2-chloro. How many carbons are there? 3. 3 carbon. It is called what? Profane. Similarly, so you have to give the number number you have to give 1. Next it is the second carbon, and this is what third carbon. Okay, first and second. So where it is a CS3 group, CS3 group is on second carbon, it is called 2-methyl, and Br is on first carbon, so it is called what 1-bromopropane. It is called what 1-bromopropane. And the next is what here, the next is common name. So some common name of what here, next is the common name of jump dihalides. Okay, next common name of this is a common name, it is no problem, it is a bromobenzene, and it is nothing but a bromobenzene. So we can write this is the bromobenzene, and this is on the meta position, it is called metabromobenzene, and it is a symmetrical because it is contains 1 and it is what 3 and what 5, so it is called what 1 3 comma 3 tribromobenzene. And the next is what here, I am discussing. This is what in common name the jump dihalides are named as alkylidene halide, and vis dihalides are named as alkaline dihalide. So here, for example, these two halogen atoms on same carbon is called what anybody geminate dihalide and geminate dihalide. So we can write what is the name it is. It is ethylidene chloride. It is called, 2 carbons are there, it is called ethylidene chloride. But here 2 halogen atom is on different carbon. So different carbon is called what? Is called what? Alkene dihalide. Alkene means what? It is a ethylene dichloride. It is called what? Ethylene dichloride. Okay, my dear students. Okay. Okay. So the next is what here? Okay. The next I can discuss. The next slide is the next slide. Okay. The next slide. Okay, my dear students. Now these are the common name and what IUPAC name. Okay. The next is here. The next is. Okay, next slide. Okay, nature of what? CX bond. Okay, nature of CX bond. What is the nature of CX bond? Okay, what is the nature of CX bond? Okay, so here the nature of what CX bond. So here, as we go down the group in the periodic table, the size of halogen atom increases. Fluorine atom is the smallest and iodine atom is the largest. Consequently, the carbon halogen bond length is also increases from what? Chlorine to what? Chlorine to fluorine, and next is what? Chlorine to iodine. Okay, so this is what chloride to what? Fluoride, and chlorine to what? Iodine. So this is what nature of CH bond. The halogen is more electronegative, so it carries what? Negative charge, and the carbon is carries what? A positive charge. So that's why. So these are polar in nature. These are polar in nature. Yes, my dear students. Next, methods of preparation. Yes. How these alkaloids are prepared? The methods of preparation. First, from alcohol. So first you take what? Alcohol. To this add what? HCl. So it gives what? Alkyl chloride. R is, and it is what? Cl. R is nothing but a alkyl. Group. What is this R? R alkyl. Alkyl group is called what? R. What are alkyls? Alkyls are nothing but a CH3. And next is what? C2H5. So these are the examples of what? Alkyl. It means when alcohol is reacts with what? Hydrochloric acid, it gives what? Alkyl chloride. Example. So R is nothing but a CH3. CH2 is nothing but a ethyl alcohol. It gives what? Ethyl chloride. Next is what? Hydrogen bromide. Next is the hydrogen bromide. In this hydrogen bromide, so all of you listen here. Yes, what is this hydrogen bromide? By using hydrogen bromide, same alcohol reacts with hydrogen bromide, it gives alkyl bromide. Where R is nothing but a alkyl. R is a alkyl. What are alkyls? CH3 group, C2H5 group. So these are called what? Alkyls. These are called what? Alkyls. So this is what with the hydrogen group. Similarly with hydrogen iodide, it gives what? Alkyl iodide. Next slide. This is the first preparation from alcohol. The second methods of preparation with phosphorus pentachloride. It's made of phosphorus pentachloride. So here with the phosphorus pentachloride, so I can discuss here with phosphorus pentachloride. So this is the alcohol reacts with phosphorus pentachloride. It gives what? Alkyl chloride. So R is nothing but a CH3 CH2. So it is what? Ethyl alcohol. It gives ethyl chloride. Next slide. And next is okay with phosphorus. Next with same phosphorus tribromide. Next with the phosphorus tribromide, same. It gives alkyl bromide and alkyl. Next slide. Next is here. Yes, this is the third method. This is the Darjan's process. So what is this Darjan's process? In this Darjan's process, it is a very with thionyl chloride. This is associated. This is called thionyl. So alcohol reacts with thionyl chloride. Is use what? Alkyl chloride. But we can't use what? SOBr2 and what? SOI2 because so these are unstable. So these are unstable. So we prefer only SOCl2. We prefer only SOCl. With the alcohol reacts with thionyl chloride, it gives what? Alkyl chloride. But SOBr2 and SOI2 are unstable. So we can prefer only SOCl2. By adding SOCl2, we can get what? Alkyl chloride. So what is the R? R is the alkyl. This is CH3 CH2. This is OH and thionyl chloride. It gives what? Ethyl chloride. Next example. Next is here from hydrocarbon. Okay, it is from hydrocarbon, so we can get what? Two isomeric product. Okay, the next is addition of halogen. It gives what? Ethylene dibromide. The next is addition of halogen. Next very important is halogen exchange method. What is this anybody? Halogen exchange method. So in this halogen exchange method, the very important is the Finkelstein reaction. What is this Finkelstein reaction? Alkyl chloride or bromide reacts with what? Sodium iodide. It gives what? Alkyl iodide. In the presence of what? Dry acetone, it is called Finkelstein reaction. So what is the Swartz reaction? In the Swartz reaction, we can use what? Alkyl chloride and alkyl bromide. But here we can use what? Metallic fluoride. We can use what? Metallic fluoride. We can use what? Metallic fluoride. So by using metallic fluoride, so we can get what? Alkyl fluoride. In the Finkelstein reaction, the product is alkyl iodide. In Swartz reaction, the product is alkyl fluoride. The next slide. The next is what? The next is the physical properties. Okay. The next is the physical properties. Okay. What is the physical properties? Just okay. So next is what is the physical properties? Okay, correct. What is the physical properties? The physical properties. Alkyl iodides are colorless when it is in the pure, and the bromides and iodides develops color when exposed to what? Light. But this methyl chloride, methyl bromide and ethyl chloride sum and chlorofluoromethanes are gases at room temperature. Higher members are liquids or solids. And for the same alkyl group, the boiling point of alkyl iodides decreases. It means the alkyl iodides are more boiling point than what? Alkyl bromide. Alkyl bromide is more boiling point than what? Alkyl chloride. Alkyl chloride is more boiling point than alkyl fluoride, because iodide is what? Iodide is what? The boiling point of alkali decreases in the order, because there is an increase in the size and mass of what? Halogen atom. So the halogen atom I is what? His mass is mass, and what size is what? More. Mass and size is what? More. So that's why. So alkyl iodides are what? Higher boiling point than, because of what? Size and what? Mass. And the boiling point of isomeric haloalkane decrease with increase in branching. For example, 2-bromo-2-methyl-propane has the lowest boiling point because of what? Branching. So 2-bromo-2-methyl-propane has lowest boiling point. Next, my dear students. The next is here. Okay. The next. Okay. Next is what here? It is okay. The next is the density. Next is what? Density. What is this density? So this density, the density is increases. The density is what, everybody? The density is what? Increases. Okay. The next slide. Next is the density. Yes, my dear students. Because the density increases with increasing number of what carbon atom and halogen atom and atomic mass of the atom, and even though these haloalkanes are only very slightly soluble in what water, not completely, they are slightly soluble in what water. Next slide. Next is the density. Density is what increases. So the next is the chemical properties. Very good. It's the chemical, just a minute. Chemical properties. What is this chemical properties? In this chemical properties, chemical nucleophilic substitution reaction. So this is Nu minus. It is nothing but a nucleophile. It is a nucleophile. It is called nucleophile. It is a nucleophile. Why it is called nucleophile? A negative charge is called nucleophile. This nucleophile, it attacks what positively charged carbon and it replaces or it substitutes what X minus. It gives a product. It gives what product. It gives what product. It gives what product. This product is called what? This product is called what? A nucleophilic substitution product. And even though this alkyl halide in which the halogen is attached, it is what type of hybridization? It is a sp3 hybridization. What is the chemical properties? First, action with aqueous state. When this alkyl halide is reacts with water, KOH, so in the product is what? Alcohol. So alkyl halide reacts with what? KOH. This OH minus is a nucleophile. This nucleophile it replaces what? It replaces what? X. It gives what? Alcohol. So it is called nucleophilic substitution reaction. Next, action of what? Sodium alkoxide. This action of sodium alkoxide is also action of sodium alkoxide is also nothing but a nucleophilic substitution reaction. It is also a nucleophilic substitution reaction. Nucleophilic substitution reaction. The nucleophilic substitution. So this is alkyl halide. This alkyl halide reacts with what? Sodium alkoxide. This alkyl reacts with what? Sodium alkoxide. So this what happens here? So this it gives what? Ether as a product. This ether is nothing but it is a nucleophilic substitution product. It is nothing but a nucleophilic substitution product. So next, what is the action of ammonia? Alkyl halide reacts with what? Ammonia. So it gives what? Primary amine. It gives what? Primary amine. Same with this action of potassium cyanide. Alkyl halide reacts with what? Potassium cyanide. It gives what? Alkyl cyanide. So these are these are the examples of what? Nucleophilic substitution reaction. These are the nucleophilic substitution reaction. Next, okay. Next example, sir. Okay, the next fifth example. Okay, fifth, sixth, and seventh. Okay, fifth, sixth, seventh. Yes, here. So it is also here. Okay, action of silver cyanide. Yes, alkyl halide reacts with what? Silver cyanide. Cn is a nucleophile. It substitutes what? X. It gives what? RNC. So this is read as a alkyl isocyanide. RNC is a cyanide. RNC, it is a cyanide. RNC is a cyanide. RNC is a isocyanide. So if it is a RCN, so it is nothing but a cyanide. It is nothing but a cyanide. It is a cyanide. But here RNC means alkyl halide reacts with silver cyanide. It reacts with silver cyanide. It gives alkyl isocyanide. RNC. There is a bond between alkyl group and what? Nitrogen. So it is read as a isocyanide. Similarly, action of potassium nitrate. Alkyl halide reacts with potassium nitrate. It gives alkyl nitrate. The same alkyl halide is reacts with what? AgNO2. It gives what? Nitroalkane. Here there is a bond between R and what? O. But here there is a bond between R and what? R and what? N. So that's why. So it is read the bond between alkyl group and nitrogen, it is a nitroalkane. The bond between alkyl group and oxygen is nothing but a alkyl nitrate. So these are the examples of what? Nucleophilic substitution reaction. The next is reaction number 8, 9, 10. Okay, 8 and it is a 9. So this is also okay. 8, 9, 10. Okay. 8, 9, 10. So it is the 8, 9, 10. In this is also same. So the action of silver salt of carboxylic acid, the silver salt of carboxylic acid reacts with alkali, it gives ester. And similarly, alkali reacts with what? Lithium aluminum hydride, it gives what? Alkane. The action of what? Lithium. The action of what? Lithium. So it gives what? Higher alkane. So from reaction 1 to 10. So these are the example of the 1 to 10 reaction reaction 1 to 10. The reaction 1 to 10 are the examples of nucleophilic substitution. Examples of what? Nucleophilic substitution. Examples of what? Nucleophilic substitution. So the reaction number 1 to 10 already we have discussed. These are the examples of what? Nucleophilic substitution reaction. Next slide. Yes. Okay. This is the elimination reaction. Next reaction number. Okay. Reaction number 10. It is the reaction number 11. Okay. So this is a very important reaction. What is the reaction number 11? In this reaction number 11, action of alcoholic potassium hydroxide, or it is also called dehydrohalogenation reaction, or it is also called beta elimination reaction. It is also called what? Beta elimination reaction. It is also called what? Beta elimination reaction. So this is the alkali. So this alkali reacts with what? Alcoholic H. The product is what? Alcohol. But the same alkali, you see here, the same alkali with aqueous KH. With what? Aqueous KH. With aqueous KH, it gives what? ROH. It gives ROH. ROH is called what? Alcohol. What is the difference is, with alcoholic KH, it gives alkene. It gives what? Alkene. It gives what? Alkene. But with aqueous KH, it gives what? Alcohol. So this is nothing but a action of what? Alcoholic potassium hydroxide. It is called dehydrogenation reaction, or it is also called what? Beta elimination reaction, because the elimination of hydrogen from what? The elimination from beta position. The elimination of what? Hydrogen. The elimination of hydrogen from beta position. So it is called what? It is called beta elimination reaction, or it is also called dehydrohalogenation reaction. Next, my dear students. Okay, the next reaction. Reaction number 12. It is a very important reaction. Setzepp rule. What is Setzepp rule? Okay, what is Setzepp rule? The very important. What is the Setzepp rule? During the elimination of hydrogen halide, this is during the elimination of hydrogen halide, HBr, the hydrogen atom must be removed from the carbon atom containing least number of hydrogen atom. So here, hence the highly substituted alkene is formed. So what happens here? So by adding what? KH, it removes us what? Hydrogen and Br. So what happened? The hydrogen atom must be removed from what? The carbon atom containing least number of hydrogen atom. Least number of hydrogen. Yes, here what happens? So it contains what? Least number. If hydrogen is removed from this carbon containing least number of hydrogen atom, so we can get what? We can get 2-butene as a major product. Okay, so the alkene is formed as the major product. Hence, this is called highly substituted. Why it is called highly substituted? So this is one substituted, and both the side is what? 2 carbon. So this is what? This is what? Only 1 carbon. Here is what? Everybody 3 carbon. So here it is what? Highly substituted. So that's why. So this is what is the Setzepp rule. During the elimination of hydrogen halide, means HBr, the hydrogen atom must be removed from what? Carbon containing what? Least number. This is the least number of hydrogen atom. So it gives what? The major product is what? Is a highly substituted alkane. Okay, this is the Setzepp rule. Next is reaction with metals. Right. Reaction with what? Metals. So the reaction with metals, it is a very important reaction. Yes, the reaction with metals. So action of magnesium. Alkyl halide reacts with what? Magnesium. It gives alkyl magnesium halide. R is a alkyl, X is a, R is what? R is a alkyl, X is a halide. Alkyl halide reacts with what? Magnesium. It gives R means alkyl, Mg means what? Magnesium. X is called what? Halide. It gives alkyl magnesium halide. This alkyl magnesium halide is called what? Grignard reagent. this alkyl magnesium halide is called what? Grignard reagent. It means, so this when this alkyl halide is reacts with what? Alkyl halide is reacts with what? Magnesium metal. So this is the alkyl halide plus what? Magnesium. So it gives what? RMGX. This RMGX is called what? Grignard reagent. And the one more reaction is the action of sodium is called what? Wurtz reaction. So this is the alkyl halide is reaction with sodium metal. It gives what? Alkane. So it is called what? It is called what? Wurtz reaction. And next is what? Next is the mechanism of nucleophilic substitution reaction. In the mechanism of nucleophilic substitution reaction, the first I am discussing here, the two types of reactions are there. The first one is nothing but a SN1 reaction. It is nothing but a SN1 reaction. So it is called unimolecular nucleophilic substitution reaction. In SN1 reaction, so we can take what? Tertiary alkyl halide. This is a tertiary alkyl halide is more reactive than what? Secondary. Secondary alkyl halide is more reactive than primary, and it is what? CS3. Which is the more reactive? Which is the more reactive? More reactive is what? Tertiary. More reactive is what? Tertiary alkyl halide. More reactive is what? Tertiary alkyl halide. More reactive is what? Tertiary. So this is the tertiary alkyl halide. This is the tertiary alkyl halide. So tertiary, which is the more reactive? More reactive is tertiary alkyl. So this tertiary alkyl slowly ionizes to it gives what? It gives what? Tertiary butyl carbocation. And next this OH minus is called nucleophile. The nucleophile it attacks for tertiary butyl carbocation. It gives tertiary butyl alcohol. It means for the SN1 reaction, unimolecular. N means what? 1 means uni. N means nucleophilic. S means substitution reaction, which is the more reactive in the which is very fast reaction in SN1 reaction is tertiary alkyl. So this is what tertiary alkyl. It is a two-step reaction. It is a two-step reaction. It is a two-step reaction. Which is more reactive? Which is a more reactive? Tertiary is what? More reactive. Next. Okay. The next is the S. What is next is about what SN1 reaction. This is very important for CET point of view. It is very important for CET point of view. Step 1 is the slowest step, and it involves the breaking of what CBr bond and energy obtained through solution of halide with the proton of protic solid. Already we have discussed. The rate of reaction depends upon the slowest step. The rate of reaction depends only on the concentration of alkyl. In case of SN1 reaction, the rate is directly proportional to only concentration of alkyl halide. Only concentration of what? Alkyl halide. So hence it is a first order reaction. Hence it is a SN1 reaction is carried out in the polar protic solvent, and which is the more reactive? So this is what tertiary is more reactive. The aromatic and benzoic halides show higher reactive towards what? SN1 reaction, and the SN1 reaction is a first order reaction. It is nothing but a first order reaction. SN1 in SN1 reaction rate is directly proportional to alkyl halide, and it is a first order, and it is also how many step? It is a two-step reaction. The next is what? SN2 reaction. Next, my dear students, so this is the SN2 reaction. So what is this SN2 reaction? So this is the SN2 reaction. This is the SN2 reaction. SN2. 2 means what? 2 means what? Bimolecular. N means what? N means nucleophilic. S stands for what? Substitution. It is what is the SN2? SN2. This is the SN2 reaction. SN2 reaction is nothing but a bimolecular. 2 stands for bimolecular. Okay. N stands for nucleophilic. S stands for substitution. It is called what? SN2 reaction. In the SN2 reaction, which is the more reactive? Tertiary. Next it is what? Primary. Next it is what? Secondary. And next is what? Tertiary. So which is have taken here? Has taken is CS3. So it is a more reactive. So this OH minus is called what? Nucleophile. This OH minus is called what? Nucleophile. This nucleophile which attacks on this carbon atom of what? CS3Cl, it gives what? Methyl alcohol. Okay. So this is about SN2 reaction. Okay. The next is what here? Next, what about this SN2 reaction? What is the SN2 reaction? This previous one, previous slide here. Not okay. It is the very important. The very important thing is, yes, the SN2 reaction. The SN2 it is a second order reaction. The rate depends on concentration of both reactant and both the reactants. Hence, it is a second order reaction. It means here the rate is directly proportional to concentration of what alkyl halide, concentration of what alkyl halide and nucleophile and what nucleophile, and it is a nucleophile. And it is a nucleophile. Okay, so here it really depends on alkyl and nucleophile. Okay, so the next is what here is a primary, secondary, and it's what tertiary. The reactant is more in what primary, then secondary, and what tertiary. Okay, so this is about the SN2 reaction. The next slide is stereochemical aspects of nucleophilic substitution reaction. So here I can discuss optical activity. What is this optical activity? Just a minute. What is this optical activity? So what is this optical activity? So the compound rotates one. Okay, the compound, the certain compound that rotates the plane towards the light through their solution. Such compounds are optically active, or it shows what optical isomerism. Optically active means shows what optical isomerism. Shows what optical isomerism. Optically active means shows what optical isomerism. Next is what? Next optical activity. Next is here asymmetric carbon. Asymmetric carbon. Okay, asymmetric carbon. Okay, it is a very important. So what is this asymmetric carbon? Okay, what is asymmetric carbon? So the spatial arrangement of four groups around a central carbon is a tetrahedron if all the substituents attached to the carbon atoms are different. Such carbons are called what? Asymmetric carbon, or it is also called what? Chiral carbon. It is also called what? Chiral carbon. It is also called chiral. So why it is called chiral? So this is what everybody I can take. This is C and this is OH, and here I can write H. And here I can write what OH, here I can write what OH, next here I can write what CS3COOH, so CS3COH. So here, okay, now here all of this here, okay, so here OH is different, okay, sorry, I can write once again, right, okay. Okay, so I am discussing here is what is meant by, so what is the asymmetric carbon? So it is asymmetric carbon is also called what? Chiral carbon. So asymmetric means what? Okay, I can write here one structure. This is H, C, CH3. Okay, this is OH, and it is what? COOH. Okay, my dear students. So here I can discuss, yes. So CS3 is different, OH is different, H is different, and COH is different. So all are what? All the four. The substitute attached to the carbon are different. Attached to the carbon are different. So it is called chiral. It is called what? Chiral, or it is also called what? It is also called what? Asymmetric. It is also called chiral or asymmetric. So what is the asymmetric? So the carbon having what? Four different groups. So it is called what? It is called chiral. And the next is what here? The next is, okay, here I can, next which is, okay, next is what here? Okay, the next I am discussing here. So this is what is the asymmetric molecule. Asymmetric means I can write H, C, here is H, here is what? H, here is also H. The groups are all are same. It is nothing but a chiral. It is nothing but a chiral, or it is also called what? It is also called what? Symmetric. It is also called what? It is also called what? Asymmetric. It is also called asymmetric. Okay. So the molecule there is no plane of symmetry and referred to as asymmetric. The symmetric molecule should obtain. Okay. So this is what everybody. So this asymmetric means what? Asymmetric means what? The substrate attached to the carbon atom has different circle. Such carbons are called asymmetric carbon. And okay, this is what is the chiral. So this is the chiral molecule, means the object which are not superimposed on their mirror images are said to be chiral. So asymmetric or asymmetric. It is a okay. Just a minute. Okay. Okay, sorry. So here this is the symmetric molecule. And what is the chiral? What is the chiral? S. So this is called chiral means what already we have discussed. So what is the once again I will repeat, asymmetric and chiral. This is what everybody H C OH CS3 CS3 COOH. So it is nothing but a chiral. It is nothing but a chiral. Chiral means what? Chiral means asymmetric. Chiral means what? Asymmetric. The next is what here? The next is what I am discussing here. The next example I can take here S. Now it is C. This is what H. This is what H. Here is also H. All the side is what H. So H it is means what? It is what? Symmetric, or it is also called what? It is also called what? Achiral. It is called what? Achiral. So same group around the carbon, symmetric or achiral. So different group is called what? Different group is different group is called what? Chiral. Okay, next slide. Next is the achiral molecule. Already we have discussed. Okay, achiral means they are the object which are superimposable on their mirror images are called what? Achiral. The next is what here? The next is what I am discussing here. What are the enantiomers? What are the enantiomers? The optical isomers, which are the mirror images of each other, or the stereoisomers, the related to each other, are non-superimposable. Non-superimposable or mirror images. Non-superimposable or mirror images are called what? Enantiomers. Okay. So next, they are not a mirror images of each other, and this is what I mean. What is achiral? Achiral means superimposable or the mirror images. The superimposable or the mirror images are called what? Achiral. But here they are the mirror images are not superimposable. It is called what? Chiral. It is called what? Chiral. What is the difference between chiral and achiral? This is called what? Achiral. It is called what? Achiral. Why it is achiral? Mirror images of each other are superimposable or achiral, or it is also called what? This is what? Which are superimposed, their mirror images is called what? Achiral. Okay, the next is what here? So what is this? They are the mirror images and non-superimposable. These are called what? Chiral. Chiral means what? Symmetric. Chiral means what? Symmetric. So this is about the achiral and what? Chiral molecule. The next slide is okay. Okay. The next is okay, racemic mixture. What is this racemic mixture? Okay, just what is this racemic mixture? What is this racemic mixture? What is this racemic mixture? So this racemic optically inactive compound or the equimolar mixture of D and L isomers are called what? Racemic mixture, or the process of conversion of enantiomers into racemic mixture. Racemic mixture means this is what? D plus and what? Minus. D and what? It has both D and L. It means the 50% D isomers and the 50% what? L. D and what? L isomers. 50% D and what? L isomers. These are called what? Racemic mixture. Next is here. Next is SN1 reaction. So next is this is an example of racemic mixture. What happens, my dear students? So already we have discussed. Yes, here what is the main thing? So this is the 2-bromobutane. So it gives L isomers and what? D isomers. Okay. Then next is what? Next is retention configuration. What is the retention configuration? Retention configuration. It is very important. Yes, here the example. What is this retention configuration? So what is this retention configuration? So during a reaction, no bond to the stereocenter is broken. the product will have the same general configuration of what groups around the stereo center as that of the reactant. The product will have, very important, the product will have the same general configuration of groups around the stereo center as that of reactant. Okay, so all of you listen here. So this is the reaction. Okay, so this is what here CS3, here is what CS3. Here is what H, here is what H. Here is C2H5, here is C2H5. So instead of Br, it is what OH. There is no change in what configuration. The product and the reactant. So they have what same configuration. Product and reactant. Here, this is the product. So this is the reactant. Okay, this is the reactant. This is reactant. And this is what product. This reactant and what product. This is what product. This reactant and the product, they have what same configuration, CS3, C2H5 and H. They have same configuration. So this type of configuration is called what retention configuration. The next is okay, retention configuration. Next example, inversion configuration. What is the next is the inversion configuration. Previous one, inversion configuration. Just a minute. What is this inversion configuration? So here, in this inversion configuration, during a reaction, the product formed as opposite relative configuration as compared to the reactant. Yes, my dear students, just a minute, just is here, the very important, just slide check, okay, next, okay, here, only the thing is what here, there is an opposite configuration, okay, my dear students, what is this opposite configuration? Okay, what is this opposite configuration? So what is here is what here? This is CS3 and it is what CS3. So here C6S13, C6S13. Here is what H and here is what. But here the configuration is opposite. This is the reactant. This is reactant. This is reactant. And this is what product. This is what product. In this what happens? So here the reactant and the product, they have opposite the configuration. They have relative opposite configuration. But in case where the here Br is on right side, but here OH is on left side, the totally the configuration is what opposite. The configuration is opposite. So it is called what? It is called what? It is called what? Inversion configuration. It is called what? Inversion configuration. Okay. The next is here. Next, the methods of preparations of haloarenes. How these haloarenes are prepared? How these haloarenes are prepared? So this by what? Electrophilic substitution reaction. This is the toluene. So this CS3. It is a CS3. It shows what plus R effect. It shows what plus R effect. Already we have studied in POC first year. It shows what plus R effect. Because of plus R effect, it gives two product. It gives what? Two product. It gives two product. One is ortho, another one is what? Para. It gives what? Ortho and para. So this is the CS3 group. It shows what? Plus Rm effect. Due to plus Rm effect, it gives two product. It gives two product. One is orthochlorotoluene. This is the parachlorotoluene. Okay. So the ortho and para isomers can be easily separated due to large difference in their melting point. These two are separated because they have what? Large difference in the melting point. Next. And fluoro compounds are not prepared by this method due to high reactivity of fluorine. The next is what? Sand-Mears reaction. So what is this Sand-Mears reaction? So in this this is a Sand-Mears reaction. So this is benzene diazonium chloride. It's treated with what? Cuprous chloride. It gives what? Chlorobenzene. This is called what? Sand-Mears reaction. And next is what here? The next is the reactions of haloarenes. Reactions of haloarenes. Okay. So here the reactions of haloarenes. Okay, just okay. Yes. Okay. Just next previous one. Yes. Just previous. Yes. Okay. So here what happens here? This is very important. So here this is the properties of haloarene nuclear. Next is the resonance effect. Here what happens? So aryl halide is less reactive. Allyl halide is less reactive than haloalkane. Haloalkane. Okay, this is haloalkane. Why? But in case in haloarenes, the aryl halides means haloarene. Aryl halides are also called what? This aryl halides are this is also called what, everybody? Haloarenes are also called aryl halides are less reactive because in aryl halides there is a partial double bond between what? There is a partial double bond between carbon and what? Carbon and what? Cl. So it this double bond it requires what? More energy to what? Break this bond. So that's why aryl halides are less reactive. Why? The CCl bond acquires what? Partial double bond. It is a partial double bond character due to resonance as a result. So the bond cleavage in haloarene is difficult than what? Haloalkane. Therefore, they are less reactive towards what? Nucleophilic substitute. Aryl halides are less reactive than haloalkane because of what? Resonance effect. In this resonance effect, so it forms what? It forms what? A partial double bond. It forms what? Partial double bond. It forms what? Partial double bond. It forms what? Partial double bond. Okay? Yes. The next is what here? Next, one more reason is, yes, second reason. Second reason of yes, all of you listen here. Yes, second reason, where is that second reason? Yes, difference in the hybridization of carbon atom. Okay, so this is also one of the reason. Yes, yes, the difference in the hybridization of carbon atom in CX bond. But in case of haloalkane, it is a sp2 hybridized. Okay, sp2 hybridized. And the sp2 hybridized carbon atoms are greater s character and more electronegative and can hold the electron pair say more tightly, and sp3 hybridized carbon atom with haloalkane with less s character because here the aryl halides are less reactive because in aryl halide it is a sp2 hybridized with greater s character, but in case of haloalkane, so it is a haloalkane with less character. For example, I can take here. So this is what? Benzene. Yes, this is a benzene. So this is next is a this is what? Haloarene. In haloarene it is what? Carbon is what? sp2 hybridized. And next is what? Next is the haloalkane. So which is the haloalkane? So this is the haloalkane. Okay, this is the haloalkane. So this is the haloalkane. So this is carbon is what? Everybody? sp3. Here carbon is sp3, but here carbon is what? sp2. So this is sp2. That's why it is a less reactive because of what? This is what? Less reactive. Okay, once again I will repeat. Okay, so what is the reason for that? Okay, yes. So now I can take here. Okay, so this is what? Remember, this is the chlorobenzene. This is the chlorobenzene. Okay, this is the chlorobenzene. This is the chlorobenzene. In this chlorobenzene, this carbon is a sp2. Next, I can take what? Methyl chloride. I can take what? Methyl chloride. So this carbon is a sp3. This carbon is a, what is this carbon? This carbon is a sp3. sp3, no, it is sp3. So this is what? sp2. Okay, so in case of sp2, it is a more s character. This is a more s character. More s character. This is what I mean. It is a less s character. Less s character. Less s character. So it is what? It is a less reactive. It is less reactive. More s character, less reactive. This is what everybody? More, this is less s character. This is less s character. Less s character. It is nothing but a more reactive. It is nothing but a more reactive because of this hybridization. So this haloarenes are less reactive than what? Methyl chloride. Next. Next is the halogenation reaction. So what is this halogenation reaction? Okay, I can discuss here. Yes. So this is the Cl group. So Cl group, it shows what? Plus M effect. It shows what? Plus M effect. It is called plus M effect. Plus M effect means two product. It gives two product. It gives two product. What are those two product? Ortho and para. Ortho and what? Para. It gives two product. Because Cl is an electron donating group. Cl is a electron donating. Because of electron donating, it gives two product. What is this? Ortho and para. So it means chlorobenzene reacts with chlorine. It gives ortho dichlorobenzene or para dichlorobenzene, or it is also called 1,2 dichlorobenzene or 1,4 dichlorobenzene. Even the similarly, this is the chlorobenzene. It reacts with nitric acid. It gives an ortho product that is called 1-chloro-2 nitrobenzene. This is the para product. It is called 1-chloro-4 nitrobenzene. Next. Next is the Friedel-Crafts reaction. Same, it is also Friedel-Crafts reaction. In this Friedel-Crafts reaction, what happens, my dear students? Yes, what happens is that this is the chlorobenzene. It reacts with methyl product. It gives ortho product that is called 1-chloro-2 methyl benzene. This is the para position. It is called 1-chloro-4 methyl benzene. Always it gives how many product? It gives two product. It gives what? Two product. One is this is the ortho product. This is the ortho product, and it gives it is a para product because the Cl is a electron donating. Why it gives two product? Because Cl is a electron donating. Yes. Next. Okay. Next. Same it gives two product. Even the sulfonation is also it gives two product. Yes. So this is what everybody saying. So this is the chlorobenzene. It is an electron donating. Electron donating. Same electron donating plus same effect, plus same effect, plus same effect. Two product. One is ortho. It gives two product. One is ortho. Another one is what? Para. So SO3 is on para position. Here the SO3H is on ortho position. It gives two products. The next reaction. Next reaction with metal. Yes, reaction with metal. In this reaction with metal, okay, I can discuss the reaction with metal. Yes, so this is what aryl halide reaction with alkyl halide. It gives alkyl benzene. So if both are alkyl halide, suppose if both are alkyl halide plus 2 NaX, it plus of 2 NaX, it is called what? Wurtz reaction. It is called what? Wurtz reaction. But here this is called Wurtz reaction because one is aryl halide, one is alkyl halide. Here both are alkyl halide. Both are alkyl halide. Both are alkyl halide. It is called Wurtz reaction. Here is one alkyl halide and one aryl halide and one alkyl halide. It gives alkyl benzene. So it is called what? Wurtz fitting reaction. Okay. So the next reaction. Okay. The next reaction. Next is the fitting reaction. Very important. This is fitting reaction. Yes, in this fitting reaction, my dear students. Okay. Yes, in this fitting reaction. This is the problem. Both are aryl halide. Both are aryl halide. So aryl halide, it is called what? It gives what? Biphenyl. Okay, my dear students. So our last conclusion. Only alkyl halide. Two types of alkyl halide. It gives what? R and what? R and what? R. It is Wurtz reaction. It is called Wurtz reaction. So one is aryl halide. One is aryl halide plus alkyl halide. Aryl halide plus alkyl halide. It gives alkyl benzene. It gives what? Alkyl benzene. It is called Wurtz fitting reaction. It is called Wurtz fitting reaction. It is called Wurtz fitting reaction. The next one is here. Both are aryl halide. Both are aryl halide. Both are aryl halide. It gives what? Diphenyl. It gives what? Diphenyl. It gives what? Diphenyl. So it gives what? Diphenyl. It gives diphenyl. It gives diphenyl. It is called what? Fitting reaction. It is called what? Fitting. So both are aryl halide. Both are aryl halide. Both are both are aryl halide. Fitting reaction. One aryl halide, one alkyl halide. Wurtz fitting reaction. So both are alkyl halide. It is what? Wurtz reaction. Okay. So you have to remember. Next slide. Last. Polyhalogen compounds. So this polyhalogen compounds. The first is and is a chloroform. This is what is the formula of chloroform? So this is yes, this is called what? Chloroform. CHCl3. It is called what? Chloroform. It is a polyhalogen compound. It is called polyhalogen. Polyhalogen. More than two halogen atom, it is called polyhalogen compound. It is a trichloromethane. It is also called what? Chloroform. This is also called what? This is nothing but a chloroform. So the chloroform is slowly oxidized by air in the presence of light to an extremely poisonous gas. Carbon and chloride is known as poison. When this chloroform is oxidized in the presence of light, so we can get what? COCl2. The COCl2 is nothing but a poison, or this it is also called what? It is also the COCl2 is called what? Carbonyl chloride. It is called what? Carbonyl chloride. This is called carbonyl chloride. Yes, when this chloroform is exposed to what? Air in the presence of light, it gives COCl2. The COCl2 is called what? Carbonyl chloride, or it is also called poison. It is called what? Poison. Next, what are freons? The chlorofluorocarbon compounds of methane and ethanes are collectively known as freons. The fluid is called what? CCl2, and it is what? F2. Chlorofluorocarbon compounds of methane and ethane is called what? It's called freons. What is the freon? This is the freon term. This is the freon term. It is a formula. CCl2F2 is one of the most common freons are in industrial use. What is the freons? Freons are nothing but a fluoro. It is a fluoro. Next, fluoro. This is what? Fluoro. Carbon compounds. It is called what? Freons. Next. Next is the DDT. So last is what is DDT? Already we all know that what is this DDT. So DDT is nothing but what is the DDT? It is a dichloro-diphenyl. What is the name it is? It is a, if I want structure, this structure, complete structure. Okay, see here. So what is this DDT? Yes, my dear students, what is this DDT? DDT, this is nothing but this is a para position, P. This is what? P dash, P dash, the para, P dash, dichloro. This is chloro, dichloro. Next, these two are called diphenyl, dichloro, diphenyl. This is how many? Trichloro. This is what? Trichloro. How many carbons? 2. It is called trichloroethane. Once again I will repeat. Yes, my dear students, what is the formula? Is once again I will discuss this, the DDT structure. What is this DDT structure? This is what? P. This is the para position. This is called P, and it is what? P. This is P. How many Cl's are there? Cl1, Cl2. So it is called dichloro. It is called dichloro. It's a dichloro. Okay, dichloro. These two are what? These two are. This is one and this is one. It is called diphenyl. It is called what? Two are there. It is called diphenyl. It is called what? Diphenyl. So how many chloros are there? 1, 2, 3. It is called trichloro. It is called trichloro. It is called trichloro. How many carbons are there? Carbon 1 and carbon 2. It is called what? Ethane. It is called what? Ethane. So it is what is the DDT? DDT is nothing but a dichloro. This is chloro 1, chloro 2. This is phenyl 1, phenyl 2. It is called what? Diphenyl. How many chloros? 1 chloro, 2 chloro, 3 chloro. It is tri. And how many carbons are there? Carbon 1 and carbon 2. 2 carbons are called what? Ethane. So this is about what? DDT, and it's a structure. Yes, my dear students. So these are the synopsis regarding what? Haloalkanes and haloarenes. Thank you. Thank you.